another algebra video for you. Today we are showing how you can verify the two functions are inverses. So this is an algebraic way to show the two functions are inverses. Say if we have two functions, say we have f and we have g. F is a rational function, x plus 6 divided by x minus 2. And g is also a rational function, 2x plus 6 in the top and x minus 1 in the bottom. If we wanted to show that f and g are inverses, and we wanted to use the definition of an inverse, then we would have to show that f of g and g of f both equaled x. So we do Fog-and-Goff, we do f of g, we put g into f, and then we do algebra and simplify, and we should get x. Not x squared, not x plus 2, just x. And then we do the other option, which is g of f, so we put f into g, and we do the algebra, we simplify. We should just get x. If we do just get x, in both of these instances, then we've shown that we've shown that f and g are inverses. So let's start. Let's talk through this. I've tried to color code it and be as clear as possible so it helps. If you have questions, please leave a comment. By the way, thanks for coming to my channel. I hope you enjoy it, and I hope you come back. So the first one we're doing is f of g. So we're plugging g into f. So remember, f is up here, x plus 6 in the top and x minus 2 in the bottom. So instead of having x, we're going to put g in for an input. And you can see that that's what I do. So I have g plus 6 in the top and g minus 2 in the bottom. So instead of having g, let's just plug in what g is. We know g is 2x plus 6 in the top and x minus 1 in the bottom. So that's what I do. I plug it in. 2x plus 6 over x minus 2, or x minus 1 in the top in place of g, and also in the bottom in place of g. Once we've done that, we look at this kind of nasty looking complex fraction, which means we have fractions within fractions. And we're like, hey, let's simplify. Let's get rid of the denominator. So we're going to get rid of this denominator, x minus 1 in the bottom of the denominators that in the fractions in the top and the bottom. And how we do that is we're going to multiply everything by x minus 1. So we multiply x minus 1 in the numerator and in the denominator. When we do that, we'll need to make sure that we distribute that x minus 1 through both terms in the top and through both terms in the bottom. Moving down, we can see that I've distributed the x minus 1 to the first term in the top, and you can see that it cancels, the x minus 1 cancels with the x minus 1 in the denominator of the fraction. 2x plus 1 over x minus 1, or 2x plus 6 over x minus 1. So that's great. We got rid of the fraction. And in the second term in the top, we need to multiply that 6 through the x and the negative 1. In the denominator, we can see that when I multiply the x minus 1 by the first term, the fraction, that again, the x minus 1 cancels with the x minus 1 in the denominator of the fraction in the bottom, which is what we want. That's what we were planning on, right? And then we also have to make sure that we multiply that negative 2 by x and then negative 2 by negative 1. Next, we've gotten rid of the fractions, so we just have 2x plus 6 plus 6x minus 6 in the top, and 2x plus 6 minus 2x plus 2 in the top, in the bottom. In the top, we can see that the 6's cancel, the 6 and the negative 6 cancel, and the bottom, the 2x and the negative 2x cancel. And we're left with just 8x over 8. And we can see the 8's cancel, and we're just left with what? What we wanted, right? We're just left with x. So that worked, right? Remember, both f of g and g of f have to be x, not just one. So let's try the other way. Let's try g of f and see if we also get x. So we have g, and we're plugging f in as an input. So g, what was g again? If we go up here, we can see that g is 2x plus 6 in the top and x minus 1 in the bottom. So instead of having an x, I put an f. So I have 2f plus 6 in the top, and I have f minus 1 in the bottom. And instead of having f, we just substitute in what f is. And again, we know f is x plus 6 over x plus 6 over x minus 2. So we substitute that in for f in the top and in the bottom. We look at it now, we're like, hey, we've got to get rid of those fractions because, again, we don't like it's just complicated, more complicated to have the fractions. So we're going to get rid of these x minus 2's in the bottoms of the fractions that we have. So we multiply everything by x minus 2. And again, remember, we've got to distribute that x minus 2 to both terms in the top and in the bottom. When we multiply the x minus 2 through both terms in the top, we can see it cancels with the x minus 2 in the bottom of the first term and leaves us with just 2 times x plus 6, which is what you see to the right here. And in the second term in the top, we need to make sure that we distribute the 6 through both terms, the x and the negative 2. That gives us 6x and negative 12. In the bottom, the x minus 2 cancels with the x minus 2 in the bottom of the first term in the denominator, which is great. And then we need to multiply the negative 1 through the x and the negative 2, which gives us x plus 6 minus x plus 2 in the denominator. We need to multiply the 2 through the x and the 6 in the numerator. It gives us 2x plus 12. And so we have 2x plus 12. Then we have the 6x minus 12 hanging out that's still being carried over. And we have 8 in the denominator because notice the x's cancel out. The 12 and the negative 12 also cancel out in the numerator. So that's great. So we're left with 2x plus 6x, which gives us 8x over 8. The 8's cancel, and we're left with just x. So since f of g and g of f both equaled x, then we know that f and g are, in fact, inverses. That's it. Hope this was helpful, and have a good day.